So here in example 3, you see that we have a system of equations. The first equation is 18x minus 3y is equal to 21. And the second equation in the system is negative y is equal to negative 6x plus 7. And so what makes this one tricky is that neither one of these equations is set in slope-intercept form. So we need to go ahead and convert each one of these first before we can graph and find the intersection, which is the solution to the systems. So in your notes with me, please go ahead and write 18x minus 3y is equal to 21. Now I want to solve this for y, so I'm going to subtract 18x from both sides to begin. And having packaged those terms together, I can use the commutative property to switch around that negative 18x and the positive 21. So it's negative 18x plus 21 on the right side. And divide both sides by negative 3. So on that right-hand side, I'm going to divide that negative 18x term by negative 3 and also that 21, that constant 21 by negative 3 as well. So this is going to be equal to then y is equal to, this is going to be 6x minus positive 21 divided by negative 3 is minus 7. Okay. So this is that first line, and you can tell that this is kind of time-intensive work. And that's where we find that sometimes graphing isn't always the best solution in terms of the best method to find a solution. So I'm going to go ahead and graph this really quickly. I know that the y-intercept is at negative 7, so here's negative 4, negative 5, negative 6, negative 7. So here's negative 7, and the slope is 6, or 6 over 1. So I'm going to go right over 1, up 6, 1, 2, 3, 4, 5, 6, and over 1 to the right. So I've got 2 points now. One here is at 0, negative 7. And one here is at negative 1, negative 1. And I can connect those 2 points with a line. I'm going to go ahead and just move that line so it's a little more clear. If I can, maybe I can't. Beautiful. Great, and so then I'm going to take that second line, I'm going to use a blue pen for that. This negative y equals negative 6x plus 7. And for this, I need to divide just both sides by the coefficient of negative 1, which is going to just change the sign of each one of the terms. So it's going to be 6x minus 7. Oh, now I noticed something really interesting here. The red equation, the first one is y is equal to 6x minus 7. Here I have this blue line, which is y is equal to 6x minus 7, meaning that when I go ahead and I graph this, I'll again have my y-intercept at 0, negative 7, and go up 6 and over 1, which means I'll have that blue line overlap the red line, meaning that they are both equations for the same line. In this case, the amount of solutions that I have for this system are infinite. So the answer here is that there are infinitely many solutions. And we'll write that in our notebooks. Great, guys, and once you have this finished in your notebooks, you have completed your homework assignment for tonight. We will continue with an entrance ticket and see how you do on these examples in the morning, and I will explain at that time where to go from there. Thanks so much, and have a good night, guys.